Conheça, Iran's premier provider of environmentally sound technologies for underground services. During the last several decades, introduction of trenchless technologies have brought about great changes in the installation of underground services, particularly in large cities. Trenchless technologies enjoy numerous technical, economic, safety, environmental, and social advantages. Technologies such as pipe jacking and micro-tunneling have enabled engineers and contractors to overcome traditional limits of open trench pipe laying techniques and are becoming increasingly important in the installation of new service pipes and sewer pipes. The intensification of global warming in recent years and the dangers it poses to the very survival of man has highlighted the urgency of sustainable development in large as well as small countries in all parts of the world. Slowly but continuously, old approaches to the installation of underground services are being replaced by environmentally friendly technologies. Conheça has played a pioneering role in introducing trenchless technologies to the Iranian water and wastewater industry by implementing the country's first sewer transmission pipeline in the ancient city of Hamadan using pipe jacking and micro-tunneling techniques under one of the world's most difficult geological conditions. Pipe jacking causes minimal disruption on construction route, so there is virtually no interference with the flow of traffic or impact on the local economy. In fact, the whole construction site can be located in a way that only one lane is blocked. Site mobilization including machines and equipment are mounted on a platform adjacent to the starting shaft. In Hamadan sewer pipeline project, the containers and some equipment were placed on top of each other to make the construction site as compact as possible. In order to install a pipeline using pipe jacking and micro-tunneling techniques, at the first stage thrust and reception shafts are constructed. The pits are either multilateral or cylindrical. The depths and dimensions of the pits depend on the slope, inclination and length of the pipeline. In the case of Hamadan sewer pipeline, the starting and reception shafts consisted of rectangular shafts of reinforced concrete with average depths of 7 meters and dimension of 20 to 30 meters. In Hamadan project, the distance from the driving to reception pits ranged from 60 to 120 meters. However, there is no theoretical limit to the length of individual pipe jacks, and under suitable geological conditions and by using the right equipment the length of pipe jacks can be increased to 1,000 meters or more. Excavation operations and consolidation of pit walls are carried out stage by stage until the desired depth is achieved. In Hamadan sewer pipeline project, all the walls of the driving pit were made of reinforced concrete. A thrust wall was also constructed in the back of the pit to provide a reaction against which to jack, and a thrust ring was employed to transfer the loads. Since the jacking frame remains in the driving pit throughout the pipe jacking operation, the floor of the pit is also covered with reinforced concrete to increase its strength. The pipe jacking machine and related equipment are transported to the driving pit by a trailer truck. After the pipe jacking machine is placed into the driving pit by a crane and aligned, ancillary parts and equipment are connected, jacking operations get underway. The cutting wheel of the boring machine rotates at the speed of approximately 3 to 4 times per minute by means of a hydromotor attached to it. Rocks and stones are crushed by the discs of the cutting wheel. The boring machine is pushed forward by a hydraulic jack situated inside the driving shaft. In Hamadan sewer pipeline project, the first pipe was jacked after the microtunneling machine and its ancillary parts, with a total length of 6 meters, had been placed into the driving pit and started excavation operations. The pipes are loaded into the driving pit one after another and jacked. This operation continues until the microtunneling machine reaches the reception pit. The control room is situated right next to the driving pit. Orders to commence jacking operation, as well monitoring, aligning and correcting the direction of the tunnel boring machine are carried out by operators stationed in the control room. Therefore, the position of the cutter head is continuously updated with the help of a laser measuring system. This laser system is positioned in starting shaft, meeting the target that is installed in the cutter head. The laser target identifies any deviation which may occur. The coordinates are transferred to the steering computer in the control room and visualized on the screen. Any deviation in direction can then be corrected by experienced operators by adjusting steering cylinders at a push of a button on the computer control panel, in accordance with the jacking speed, ground conditions and inclination of the line. To remove the material excavated by the cutting wheel, water from tankers located outside the driving pit is transferred by the feed pump to the tunnel face. The mixture of water and excavated material is transferred by the tunnel pump to the driving pit, where the slurry discharge pump removes the excavated material and pumps it to the separation plant. Thus a closed circuit, whereby the spoil is continuously removed from the system and clean water returned to it, is created. Friction is one of the most difficult challenges facing microtunneling and pipe jacking techniques. Friction increases with pipe diameter, as a greater surface area of pipe is presented to the internal surface of the bowl. In Hamadan sewer pipeline project, the problem of friction was addressed by using a suspension of bentonite mud. This suspension was pumped to the cutter chamber via a system of pipes arranged within the jacking pipe. In Hamadan sewer pipeline project, Conheça used polymer concrete pipes and built a manufacturing plant to ensure a steady supply of quality pipes at the right time and cost. Polymer concrete pipes have many advantages, including durability, longer useful life, high compressive strength, corrosion resistance, reduced skin friction, smooth, even, non-porous outer pipe surface, ease of installation, and uniform distribution of jacking forces. Trenchless technologies such as pipe jacking and micro-tunneling also have numerous environmental, social, and economic advantages when compared to open-cut pipe laying methods. In a recent study, the International Pipe Jacking Association compared the environmental, social and economic aspects of open trench and pipe jack sewer construction in a 100-meter long, 1,200 mm diameter, 4-meter deep pipeline. The results were as follows. Excavated width, in open trench 2,350 mm, in pipe jacking 1,450 mm. Reinstatement width, in open trench 2,650 mm, in pipe jacking, none. Excavated volume per meter of pipeline in open trench 18.27 tons. In pipe jacking, none. Number of 20-ton lorry loads per 100-meter pipeline in open trench 320. In pipe jacking, 21. Main advantages of pipe jacking and micro-tunneling techniques. Earth moving is minimized, thus optimizing time and cost. No groundwater lowering is required, thus preventing dangerous settlements of building foundations and disruption of road services. Optimum protection for workers, general public, and environment. Traffic flow and nearby businesses are not affected. Construction work is not influenced by weather, enabling contractors to meet deadlines and budget constraints. Enables engineers to drive a curved alignment. Trenchless technologies in general, pipe jacking and micro-tunneling in particular have the potential for significantly improved social, economic, and environmental performance relative to other technologies. Trenchless technologies are constantly pushing back the boundaries of all forms of underground work required to support human settlements. Engineering innovations and process improvements enable clients and contractors to increase pipe diameters and the length of individual pipe jacks, improve speed and precision. Where previous work was limited to depth dictated by safe open-cut methods, depth is no longer a limiting factor. Where services already exist, they can be refurbished. And where new services are required, they can be constructed beneath the existing structures, under rivers and even open seas. Most importantly, trenchless technologies help us conserve resources, protect the environment, achieve sustainable development and build a better world for future generations. As one of Iran's leading designers and builders of environmental infrastructures, Conheça hopes to build a greener world by employing advanced technologies in promoting environmentally sound approaches to the construction of underground services.